Hi 30-2s. This is going to be the second lesson for polynomials, solving polynomial equations. I think it's on page 10 in your booklet. So it says last year we learned some different ways to solve problems involving quadratic relations and functions. So we're going to kind of review that stuff today. And then eventually we'll get into regressions, which is actually the next lesson beyond this. So we'll extend these to other functions and add a new method. So x-intercepts or zeros or roots or solutions, those different terms are actually kind of used interchangeably in this. So last year we learned that a function has the form f of x or y equals x squared minus 2x minus 3. So where it has a variable in relation to another variable. But we also have an equation where it's a variable equal to a number. So is equal to 7. So you're looking for the values of x that actually make that true. You can kind of tie in some of those principles that we saw with our rational expressions as well. So here we have functions versus equations. So if this is a function, again, you can write y equals x squared minus 2x minus 3, or you can write f of x. And so a function is not equal to a number. It will produce an entire graph, and it potentially has zeros or x-intercepts. Again, sometimes you can have a quadratic that doesn't have any zeros, and that's okay. So a function overall cannot be solved. So you can get pieces of information out of it, but you're not necessarily solving it. You're not looking for the value for x that makes it true. Whereas when we get over to equations, so now we have them equal to something. So equal to 5, equal to 3. And so depending on what you do, you can produce two graphs. So if you're doing it this way, which we'll talk about, and it has roots, it has x-intercepts potentially. So your roots are equal to your zeros are equal to your x-intercepts in the case when it's equal to 0, whereas if you have it equal to a value, your solutions or your roots are equal to the x-coordinates of the point of intersection with the graph. So for either equation, whether it's equal to 0 or equal to a different number, the solutions are the values of the variable which make the equation true, which make the equation equal, whatever you want to call it there. So an equation is said to be solved. See, I'm going off the edge of the page here. It's said to be solved if your left-hand side of the equation is equal to the right-hand side. So once you solve it, you can substitute in your value for x, and it should make your left-hand side equal to your right-hand side of the equation. And so we have a few ways that we can solve equations. So the last one is doing a regression. And again, that'll be the next lesson. But today we'll look over all these ones yesterday that we did, or all the ones that we did last year for quadratics. My apologies there. So factoring is an algebraic method. So you can factor it and determine what values make those factors equal to 0. The quadratic formula, so obviously that's only for quadratics. You can't do it for cubic functions or linear functions. It's also an algebraic method. And graphically. So graphically is one that you always have. Even if I ask you an algebraic way of solving it, you can always double check your answers with solving it graphically. So we'll look at factoring first. So going back to last year, so again, we have a quadratic function here, or this is a quadratic equation because it's equal to 0. So x squared minus 2x minus 3. So we could factor that by inspection. You could do it by decomposition. So where we're looking for two numbers that multiply to be equal to -3 and add to be equal to -2. So I know if it multiplies to a negative number, that means one needs to be positive and one needs to be negative. And since it adds to a negative number, that means my higher number needs to be the negative. So my factors of 3 are only 3 and 1. So I know it needs to be -3, +1. That will satisfy those particular processes that need to occur. So those multiply to be equal to -3, add to be equal to -2. So my factored form of this trinomial, this quadratic, is x plus 1 and x minus 3. So that again is factored. So the only way to get an answer of 0 is if one or both of the factors are equal to 0. So what we want to analyze is what makes each of those factors equal to 0. So we have x plus 1 and x minus 3. So again, this is analyzing both of these factors. What makes them equal to 0? Because if either of them are equal to 0, that will make the whole left-hand side of your equation equal to 0. So we know to solve for what values for x would make this true, we just need to isolate x. So x plus 1 is equal to 0, so I'm going to subtract 1 from both sides. So if x is equal to -1, that will work. And I'm going to add 3 to both sides. So x is equal to positive 3. And so it says here, solve each of these simple equations for x to find the x-intercepts, or the zeros, or the roots, or the solutions. So we have two solutions. And you would want to verify them each independently. By substituting into the original equation. Again, we did a lot of this in 20-2 in quadratic, so I'm not going to go over it, but again, you should actually verify your solution. Both of those work. And we'll talk about other ways you can verify other than substitution, but we're just trying to refresh ourselves on the process. So the next one says solve the equation x squared minus 2x minus 3 equals 5 by factoring. And it says be careful, there's a twist. So what we see right now is it's equal to 5. So if I, don't start writing this down because I'm going to erase it immediately. If I factored this as x minus 3, x plus 1 equals 5, now what I would need to do is figure out what these two multiplied together to would be equal to 5. And that would be really hard to figure out. So what's our best case, or what we should be doing, is set it equal to 0. So we need to, since it's equal to 5, we need to set equal to 0 in order to solve for x. So I'm going to subtract 5 from both sides of the equation. And so now we would have x squared minus 2x minus 8, because -3 subtract 5 is -8, is equal to 0. And now when we have it set equal to 0, we can factor it. So again, we've reviewed factoring already, so I'm going to kind of zoom through this. But we're looking for two numbers that multiply to be equal to -8 and add to be equal to -2. So we're looking at x minus 4 and x plus 2. So that's my factored form of the trinomial quadratic that we have above. Is x minus 4, x plus 2. And again, analyzing what would make each of those factors equal to 0, just like we had above. Our solutions are x equals 4 and x equals -2. So two solutions. Again, you'd want to verify that they both are legit. But we're trying to get through a lot, so we're not going to actually do it, but you should on the day-to-day. So on to the next one. So solve the equation negative x plus 3 times x plus 1 times x minus 2 equals 0. So this actually, if we multiplied this all out, this is a cubic function. I will not ask you to factor a cubic function because we don't actually have that piece of information for how to factor it at this level. So if I give you it in factored form like we have here, you can figure out stuff, but I won't give you like a 4-term one with a cubic function and be like, well, factor this, because we actually don't have the skill that you would need in order to factor that. So it's already in factored form. So again, all we need to do is look at each of these factors and figure out what makes any of them or all of them equal to 0, because then it will make the entire left-hand side equal to 0, which is the same as equal to the right-hand side. So in order to make x plus 3 equal to 0, x would need to be equal to -3. In order to make x plus 1 equal to 0, x would need to be equal to -1. And in order to make x minus 2 equal to 0, it would be x equals +2. So those are our solutions that would make the left-hand side equal to the right-hand side. So again, if it's in factored form, you just analyze each of the factors or solve each of the factors to figure out what is equal to 0. So the next one, so solve the equation x squared plus x minus 4 equals 0 by factoring. And so you'd sit here and you'd be like, I need two numbers that multiply to be equal to -4 and add to be equal to 1. Okay, 4 and 1, no, 2 and 2, no. So this is, we can't actually solve by factoring. So it's asking what's the problem. Can't solve by factoring. So either there is no solution or the solution is actually a decimal. So we can't say automatically just because you can't factor it that there's no solution. It's just not easily factored because there are no two integers that would multiply to be equal to -4 and add to be equal to +1. So that's the problem. It's not easily factored. That doesn't mean that there's no answer necessarily. It's just not easily factored. So if a quadratic cannot be factored, we can either graph it, which we'll see a little bit later, or use the quadratic formula. So we'll talk about the graphical stuff later. We don't need to fill out the rest of that chart. So the quadratic formula, this was a big beast that you did in 20-2, and it will be on your data sheets. So just to refresh you on what it actually is, so x is equal to -b, and then there's a plus and a minus here, so it looks like that, plus or minus the square root of b squared minus 4ac. So that's all under that radical symbol. It's all part of the radicand, divided by 2a. And again, in order to use the quadratic formula, you need to have it in the form ax squared plus bx plus c equal to 0. So you need to have it set equal to 0 and everything gathered properly with their like terms. And so I think this is the question from the last page. So x squared plus x minus 4 is equal to 0. So just looking at this, so my a value, again, there's ones here if you don't see any numbers. So a is equal to 1. Our b value is the number in front of your x to the power of 1. So b is equal to 1. And our c value is equal to -4. So all it is now is plotting it or plugging a, b, and c into this big beefy guy up here. So x equals, so -b, so -1 plus or minus b squared, 1 squared, minus 4 times a times c, so a is equal to 1, c is equal to -4, divided by 2 times a. Now, I would like to give us all the benefit of the doubt and say we are amazing at calculators and we can punch this all in at once. But in my vast experience, we are not all amazing at calculators and we struggle to punch it all in at once. Plus, we kind of want to get our exact answers for this. So I would say start simplifying things. All right. So -1 plus or minus. So 1 squared is 1. 4 times 1 times, negative 4 times 1 times negative 4 is 16. Oop. 2 times 1 is 2. So I've just kind of simplified a couple of the, oh, that was too much, a couple of the steps up to that point. I'm just going to keep simplifying. I left myself lots of space for this reason. So we have x equals negative 1 plus or minus square root of 17 over 2. So we have two situations out of here. We have x equals negative 1 plus the square root of 17 over 2. And we have the other situation of x equals negative 1 minus the square root of 17 divided by 2. So these two answers, even though they look real dumb, these are the exact answers. And this is probably what I would be looking for actually on a test, is an exact answer. We could look at our rounded answer. So if you punched in negative 1 plus the square root of 17 divided by 2, you get 1.56. And if you put in negative 1 minus the square root of 17 divided by 2, you get negative 2.56. So these are our rounded answers. Sorry, that's almost impossible to read. Those are our rounded answers or our decimal answers. But there was actually a solution for the one on the last page where we said it didn't easily factor. So there is a solution. It's just not a nice round answer like we had before. Is this the whole page? All right, so use the quadratic formula to solve x squared plus x minus 4 equals 3. So again, there's a twist. Man, I have lots of hints. The twist is that it's equal to negative 3. Up at the top on that last page, you saw it needs to be equal to 0. So we need to set that equation equal to 0 in order to use the quadratic formula. So we need to set equal to 0 in order to use the quadratic formula. So I'm going to add 3 to both sides. What I do to one side of the equation, I must do to the other. So negative 3 plus 3 is 0. Negative 4 plus 3 is negative 1. X squared. So x squared plus x minus 1 equals 0. So now we can start to look at our values for a, b, and c. So a is the value in front of x squared, so a is equal to 1. B is also equal to 1. And c is equal to negative 1. That's pretty easy, but missing a negative symbol can have a real big impact. So into the quadratic formula, again, x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So slotting in all those a's, b's, and c's based on this. So negative b, so negative 1 plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. So again, don't be a hero. Simplify it as you need. So 1 squared is 1. Negative 4 times 1 times negative 1 is 4. Positive 4, that is. 2 times 1 is 2. Okay, so we're at our two situations now. So we have negative 1 plus the square root of 5, because 1 plus 4 is 5, divided by 2. And we have negative 1 minus the square root of 5, divided by 2. So again, this is the quadratic formula. So we have two answers there. That would actually make the equation true. So when you would try to verify this question or the last, you might use your rounded answer with a whole bunch of decimals. And you might get like 0.0004 equals 0. Yeah, it's just because you're using your decimal approximation to verify by substitution. It's all good if it's something like that. If you got like 7 equals 0, no dice, that's not good. But if you're pretty close to 0, it's probably just because you're using a decimal approximation. Oh. So use the quadratic formula to solve negative x cubed minus 2x squared plus 5x plus 6 equals 0. What's the problem? It's not a quadratic. You can't use the quadratic formula if we have a cubic function or a cubic equation. Quadratic. So you can't use that quadratic formula for something that's not a quadratic. You can't solve a linear, you can't solve a cubic by it. So when we hit that point, if it's a big old cubic function, I'm not going to ask you to try to factor this. I've already said that I won't ask you to factor a big old mean cubic function. We can't use the quadratic formula, so what you can definitely use is graphically. So we're going to talk about two methods, but we're going to talk about one method and then we're going to call the other one kind of silly because we should just be using our method one where we set it all equal to 0. So it says if we have an equation equal to 0, like the one that we had before just above, then what we do is we graph the equation into y1 of the calculator. So you put it in y1, make sure you're very careful with your negative symbols and your exponents threes and all those sorts of things. And then you, depending on if you're looking at the Casio or the TI, so if you're looking at the Casio, again, pull out that bright green sheet and look at how you solve for your x-intercepts. I believe it's called roots in the Casio. I don't have one with me, but I believe it's called roots. On the TI, you press second, calculate, and number 2 is, it says zeros of the equation to find the zeros or x-intercepts. Actually, on the Casio, now that I'm thinking of it, it might be called x-intercepts or it might be called roots. I don't remember. It's one of those two things, but that green sheet has the instructions for how to find your x-intercepts. And so we do this because when an equation is equal to 0, like it is here, when we have it set equal to 0, the roots are equal to the zeros, which are equal to the x-intercepts. And that's why I said before that we use the word zeros and solutions and roots and x-intercepts kind of interchangeably if we have it set equal to 0. So an example of this, so I think it's up on the next page. So this is that same equation. So what you need to do, you might want to try this before, is graph it, pause the video, and graph it in y1. So put it into y1, pause the video, graph it, and just make sure that you can actually find that graph on your calculator. You can figure out your zeros or your x-intercepts. I'd recommend doing that yourself because just copying down the ones that I write doesn't mean you have the skills when a test or an assignment pops up. And so when you graph it out, so we're going to get a couple of points here. So you need to, I wouldn't just sketch randomly what you see. You probably need to get pieces of information about your y-intercept and like your local minimums and maximums, like your little partial vortexes. But it's going to look something like this. Continuing in that direction and that direction. Yeah, hopefully I got them all right. So when you trace each of these independently, so again, Casio, I forget if you're looking for roots or x-intercepts, you're going to find 1, 2, 3. TI, you're going to have to do that left bound, right bound in total 3 times because there are 3 spots. So what you're going to find is your zeros, or your x-intercepts, however you want to call it, are at -3, 0, -1, 0, and +2, 0. So graphically, as long as you know how to work the calculator, it's pretty darn easy if you know how to find your zeros, as long as you graph it all in and can find your graph easily. And again, what you'd want to do is verify each of these on their own. So just to give you an idea what I mean, since I haven't really been doing it, let's verify that first 0 that we have. So that first 0 we had as -3. So anywhere there's an x, I'm going to put in a -3. So -3 cubed minus 2 times x squared plus 5 times -3 plus 6. I'm going to write equals 0 over here because I ran out of room. So -3 cubed is -27. So -27 is going to be +27. -3 squared is 9. 5 times -3 is -15, and 6. So 27 minus 18 minus 15 plus 6. So +27 minus 18 is 9, minus 15 is -6, plus 6 equals 0. And so because 0 equals 0, we are happy. And you'd want to do that again 3 times because we have 3 solutions. So you'll always want to be verifying your answers. Again, you can know when it doesn't match up. So the second method for graphing, I find, is a little bit dumb, but to each their own. So right now we have, it says if we have one equation equal to another equation. So x cubed, sorry, -x cubed minus 5x equals 2x squared minus 6. So we have something equal to something. My personal opinion at this point is you should just do minus 2x squared plus 6, and what you do to one side, you do to the other, and then what you would get is -x cubed plus 5, oh, I should write it in order, I guess, minus 2x squared plus 5x minus 6 equals 0, and then do what we did with the last question. I think it's the easiest to set it equal to 0, because this one, if we actually do it the way it's saying, so we put this side into y1, and this side into y2, and then trace the points of intersection. Oh, I guess I'm not really following the thing. So you use second calculate in the TIs. Number 5 is tracing the point of intersection. I think the green sheet has it for the Casios as well, but I can help you if not. So you're finding the x coordinates of the points of intersection of the 2 graphs. So it's plotting 2 graphs, and what you need to do is find where they're equal to each other. So we do this because when one function equals another function, the solutions are where the equations are equal to each other. So I'm just going to really lightly do this, but your first graph, so the one that has x to the power of 3, it looks something like this. Your other graph, so this is your cubic one. Again, I'm not paying attention to where everything is. The other one, like, I guess this needs to go at more of an angle like this. The other one like crosses here and here and here. But you have to massively expand your window to see all 3 points of, oh, I think I gave myself 4 points of intersection. Didn't do that right. But there were 3 points of intersection. So I guess this line shouldn't go out here, it should kind of be internal. So a point of intersection here and a point of intersection here. It's annoying. I can show you. Oh, I don't have my key open, so I actually can't. I did a little bit better on my key, but I actually wrote myself a note that says, oops, I messed it up and it doesn't quite match up. So even when I tried hard to graph it, it didn't quite match up properly, but we have our 3 points of intersection. And so the coordinates of the point of intersection, again, we just care about the x values of the point of intersection. So at -3, -1, and +2, and that gives us our solutions that we actually had. Ooh, up above. Ooh, I closed it down. So that gives us the solution that we have up above. And again, you want to verify it independently, making your left-hand side equal to your right-hand side. Not equal to 0 in this case. But again, let's use method 1. It's so much easier. And so it says D, regression models. So regression models will be our next lesson. It's a big calculator thing, and we're going to see it a lot. So you have on page 14 some homework problems. Try doing some of the quadratics ones. So question 2, question 4, question 2 and 4, you can try doing it algebraically by factoring or the quadratic formula. Most of the other ones, you're going to use your graphing calculator to figure it out. All right, that's it. That's all. Talk to you later.